Hi, I'm Dr. Incognito. In this video, we're going to solve an integral using partial fraction decomposition. And in this particular example, the denominator will have a repeated linear factor. So the example will be the integral of x squared plus 3x plus 1 over x cubed minus 4x squared plus 4 dx. So the first thing we want to do when integrating a rational function like this is to completely factor the denominator. So x cubed minus 4x squared plus 4x, excuse me, that was supposed to be 4x, plus 4x, we can factor out an x to give x squared minus 4x plus 4, and then we can factor the quadratic as x minus 2 times x minus 2. In other words, x times x minus 2 squared, and we have here what's called a repeated linear factor. So the partial fraction decomposition of the original fraction will have the following form. It will have the form a over x for the factor of x, and then for the repeated linear factor, we will have b over x minus 2 plus c over x minus 2 squared. So this is the form of the decomposition. And the whole point of the using the partial fraction form is now we can integrate. The integral of a over x will be a times the natural log of the absolute value of x. The integral of b over x minus 2 will be b times the log of the absolute value of x minus 2. And then the value of the integral of c over x minus 2 squared, for that, we'll look at this. The integral of 1 over x squared, that would be the integral of x to the minus 2, integral of x to the negative 2, that's x to the negative 1 over negative 1. In other words, negative 1 over x. So a modification of that 1 over ax plus b quantity squared, we can do a u substitution. We'll end up with something very similar to this, negative 1 over a times 1 over ax plus b plus c. So this third term, the integral will be negative c over the a value in this example. The little a is 1. So c over 1 times 1 over x minus 2. Plus a constant of integration, which for the moment I'll call k, since the letter c is already being used for something else. So that's basically the answer. The question is now, what are the values of a, b, and c? So to figure those out, we'll go back to this equation, set these fractions equal to each other, and solve for a, b, and c. So x squared plus 3x plus 1 over, I'll write the factored form, x times x minus 2 squared is equal to a over x plus b over x minus 2 plus c over x minus 2 squared. So set those equal to each other. And now clear the equation of fractions by multiplying both sides by x times x minus 2 squared. We get on the top x squared plus 3x plus 1 on the left side. And on the right side, a times x minus 2 squared plus b times x minus 2 plus c times x. We're multiplying by this quantity. So for example, in the middle fraction, when you multiply b over 2 times this quantity, one of the x minus 2's cancel, and you're left with the x and the x minus 2. So there's the b times the x and the x minus 2. Now let's start plugging in some favorable values of x. Let's try letting x equal 0. On the left side you get 1, and on the right side it'll be b times 0 and c times 0, so we'll just get a times negative 2 squared, which is 4. And that immediately tells us that a is 1/4. And so that's going to go right there in the final answer, 1/4 log absolute value of x plus etc. Another value that we could plug in would be x equals 2. That way x minus 2 will be 0, so we'll get a times 0, and here we'll get b times 0, so we'll be left with c. So let's see, if x is 2, then this is 4 and 6 or 10, 11 is equal to 2c. So c is equal to 11 over 2. So I'll put that in a moment in the final answer. Let's figure out b first. So to figure out b, let's choose any other value of x. How about x equals 1? If x is 1, then the left side is 5. And the right side is, that's 1. Negative 1 squared is 1 times a is 1/4 plus b times 1 times negative 1, so that's actually minus b. And then plus c, c was 11 over 2, so plus 11 over 2. If we multiply both sides of this equation by 4, then that will give us 20 is equal to 1 minus b plus 22, 4b. Multiply both sides by 4, we get 4b plus 22. So altogether, 4b is equal to 3. Moving the b's to the left and the numbers to the right. 23 minus 20 is 3. So b is 3/4. And we said c was 11 over 2. We've already put a in the answer. So the rest of the answer is b is 3/4 log x minus 2 minus c is 11/2. 11/2 times 1 over x minus 2 plus the constant of integration. So that's the final answer. So the key is the form of the decomposition. When you have a repeated linear factor, x minus 2 quantity squared, then we're going to get two fractions in the decomposition, one with x minus 2 to the first power, and the next one with x minus 2 to the second power. And the numerators of those fractions will simply be constants. So thank you for watching this video. I hope you found it helpful.